Imagine glancing up at the star-spangled night sky and realizing that each point of light could harbor worlds unknown. Each flickering star a sun to its own solar family of planets. In 1995, science fiction nosedived into the realm of scientific fact, when the first confirmation of a planet orbiting a sun-like star outside our solar system, coined as an exoplanet, was made. Since then, the hunt for these celestial bodies has unfolded like a cosmic detective story, filled with unexpected twists and startling revelations about the universe we inhabit. The exploration of exoplanets isn't just a quest into the unknown, it's a journey that mirrors our deepest ancestral yearnings to understand our place in the cosmos. It's an odyssey that questions, are we alone? And in doing so, challenges our very perception of life, existence, and the infinite reach of our universe. The path to the first exoplanet discovery was paved with technological innovation and astute observations. Michel Mayor and Didier Queloz, two Swiss astronomers, heralded the modern age of exoplanetary science in 1995 when they detected 51 Pegasi b, a gaseous giant orbiting its star in what seemed a blisteringly fast 4.2 days. This discovery was groundbreaking. It defied the then accepted models of planetary formation and prompted a worldwide race to find new worlds. The initial disbelief in the astronomical community quickly turned into excitement. With improved detection methods like the transit photometry and radial velocity techniques, astronomers began uncovering exoplanets at an astonishing rate. Each new find, from rocky Earth-like planets to gas giants dwarfing Jupiter, hinted at the sheer variety and richness of planetary systems in our galaxy. The truth is, our exploration of the heavens has dramatically shifted since the days of Ptolemy. Today, space-based observatories like Kepler and TESS have turned exoplanet discovery into a nearly routine affair, cataloging thousands of alien worlds that remind us of the limitless potential our universe holds. Exoplanets are as varied as the stars they orbit. They range from fiery inferno worlds skimming their parent stars, to ice giants shrouded in perpetual winters, stretching our imagination and scientific models. These planets are primarily classified into several broad categories based on their mass, composition, and orbit: terrestrial, gas giant, ice giant, and rogue planets without a star. Understanding the vast array of exoplanetary environments requires advanced models and simulations. For instance, the composition of an exoplanet can influence its ability to support an atmosphere, which in turn affects its surface conditions and potential habitability. Employing techniques such as spectroscopy, scientists can analyze the light passing through an exoplanet's atmosphere, gaining insights about its weather patterns, chemical makeup, and even the possibility of life-sustaining water vapor. The study of these distant worlds isn't merely about adding new entries into astronomical catalogs. Rather, it's about piecing together the intricate tapestry of our universe's structure and contemplating the yet-to-be-answered questions about life beyond Earth. The field of exoplanet research brims with milestones that have pushed the boundaries of human knowledge. Recalling a few, in 2014, the Kepler Space Telescope identified Kepler 186f, an Earth-sized planet within its star's habitable zone, sparking imaginations about its potential to harbor life. Then came Proxima Centauri b in 2016, an exoplanet orbiting the closest star to the Sun, further accentuating the possibility of interstellar travel in the future. Each discovery serves as a stepping stone towards deeper understanding and appreciation of the cosmic cornucopia of worlds. Whether scrutinizing the atmospheric composition of GJ 1214b, a water world, or detailing the brutal surface conditions on WASP-12b, these findings not only deepen our understanding, but also refine our search methods and targets in the quest for Earth-like planets. Moreover, these discoveries hold philosophical significance, provoking thought about our existential solitude or plurality in the universe. They remind us of our pioneering spirit, pushing the technological envelope to glimpse farther into the dark stretches of space. As our technological prowess sharpens, so too do our horizons expand. The next generation of space telescopes, like the James Webb Space Telescope and the European Extremely Large Telescope, promise to propel our understanding to new heights. These behemoths are designed to pick apart the light of distant stars and their circling planets with unprecedented precision, potentially identifying signs of life. The prospects of detecting biosignatures, signs of life such as oxygen, methane, or even industrial pollutants, in an exoplanet's atmosphere electrify the scientific community. Such a discovery would arguably be among the greatest in human history, reshaping our understanding of life in the universe, and perhaps even guiding our future as a species on this planet and beyond. In conclusion, the study of exoplanets is an enlightening journey through time and space, teaching us not only about distant worlds, but also about Earth itself. By looking outward, we learn more inwardly, viewing our planet as one thread in the broader cosmic fabric, interconnected and vibrant with potential. As we continue to explore, we keep unraveling the mysteries of the cosmos, constantly reminded that the universe is far more majestic and varied than we could have ever imagined.